action. So, so write mother functions. Nice, thank you. Take home. Beautiful. So, let's take a look at this on Desmos. And if you're got Desmos open, you should be doing the same thing. So my function f of x equal to x squared minus 2x minus 1 all divided by 3x minus 5x squared. And what's weird about this is like there's not much to do, right? So you think, well, I must be doing something wrong if there's not much to do, but you want to put words down on the paper, right? You want to put something down on the paper that shows me that you have an understanding. If you just have minus 1/5 on the paper, how do I know where you got it from, right? So I want some kind of understanding. So, but if I graph y equals minus 1/5, you can see it on my curve that my function on the right is getting really, really close to that blue line from above. The function on the left is getting really, really close to that blue line, but from below. And you see, I can cross a horizontal asymptote near the origin, okay, in the short run, I call it. So my red function crosses the horizontal asymptote in the short run, but not in the long run, not way at the ends. Rancuni, does that help at all? And so I guess you're going, so now if you look at my solutions there, for number 9, right? I did exactly this. I said, well, as it gets really large, it's behaving like the mother of the top over the mother of the bottom, right? All right, next one is number 11. Sorry about the pen. That says number 11, believe it or not. A sine table for x squared minus 1 over x squared minus 9. I like this problem, and it's greater than or equal to 0. So I definitely want to graph this, okay? Because it's going to help you know the answer is correct, that the answer that you get is correct. So x squared minus 1 over x squared minus 9. And it's looking like everything on the left is above the x-axis, so greater than 0. Everything on the far right is above the x-axis, so greater than 0. And there's one little piece in the middle where it's going above and hitting 0. Right? You with me there? Do you see it though? Yeah, so watch what I do here. I go gearbox, I go table, and let me plug in -10. When I plug in -10, do you see the point it created? Is that above the x-axis or above the, I'm sorry, is it above or below the x-axis? It's above. It's positive. When I plug in -1, it hits 0. When I plug in 0, and these are all these points, right? When I plug in -1, it hits 0. When I plug in 0, it hits some positive number again. When I plug in +1, it hits 0. When I plug in +2, right, at this point, yes, it's below ground. It's negative. If I plug in 5, where did it hit on the graph? It hit it again at a positive height. Right? What height? 1.5. That's a positive number. Yes, you with me? Okay. So, but back to the work now. So we know the answer already just by looking at the graph. And in fact, if you take calculus with me, you'll see I'm going to use the graph to get you to understand the calculus, but then I want you to show me the calculus verifies the graph, and we're doing the same thing here in pre-cal. I already know this answer. I don't have to do any work, but I want you to be able to do the work as I've been showing you. So sine table. I want to factor f of x first. Oh, my pen's back alive. X plus 1 and x minus 1 is upstairs. Downstairs is x plus 3, x minus 3. Factor, yes? Critical values. What are they? Yeah. And I know this is a little unfair or harsh for me to say it, but I expect you to know how to factor polynomials. If you can't factor polynomials, and that's not a part of this class, quadratics, I'm sorry, right? Because we learned how to factor larger than quadratic. So, but if you're having trouble factoring these quadratics, you got to go learn it, or come see me, right? Say again. Yeah, exactly. Yep. So I'm waiting for Wankuni, okay? Yep. So I'm going to find my critical values. What does it say on my formula sheet? It says critical values are when the numerator is zero, x values that make the numerator 0, or x values that make the denominator 0, right? So, and I like them in order. I definitely know it's x equals plus or minus 1 or plus or minus 3. But for my sine table, I want them in order. So -3, -1, +1, and 3. Right? So factor the function, find the critical values. We'll do a lot of this in Calc 1. Okay? I want to create my table now. And so I'm thinking of the number line as kind of the top of my table. And my critical values, right, showing here. And I'm going to put a circle on the negative and positive 3, and a solid point on the -1 and 1. Why am I doing that? Because -3 and 3 are trouble, aren't they? What would you call -3 and 3 here? Nope. Yes, vertical asymptotes, and they're the numbers that are not in the domain, right? So I can't use them. I can't say you can plug in a 3. You can't. But I can plug in the plus or minus 1, right? I can plug those in. And you already saw I got 0 when I plugged those in. So this thing is separating my columns. So my columns are created by my critical numbers, including the endpoints of the domain. And my rows are created by the factors, which I have 4 factors, and then one final function, f of x. So my factors in any order, x minus 1, x plus 1, x minus 3, x plus 3. You can't watch me parallel park and expect to parallel park like I do. I don't do any of that nudging back and forth crap. I just one shot back in, done. So you can't do this just by watching me do it. You have to sit there and create it. And the first time you create it, you might be like, "Oh, that doesn't look right," or I had one less column that I needed. Right? Now, what am I doing? I'm picking test values, left of, right of, and in between all my criticals. Left of, right of, and in between all my criticals. So, for example, -5 is fine. How about -2? How about 0? How about 2? How about 5? I do like to be symmetrical about it if I can. Sometimes I can't. Yes. Anywhere left of, right of, and in between. So I could have picked 9 minus 500 for my first test value. And again, look at what I'm doing on Desmos here. -5, above ground. minus 2 below ground, 0 above ground, 2 below ground, 5 above ground. It's giving me the answer, right? So I'm going to use Desmos. It's going to tell me. And all I'm looking at is the sign. Do you see positive, and then negative, and then positive, and then negative, and then positive, right? And I'm just trying to clear out some of these other numbers so they don't bother anybody. I guess I can't. That's fine. So now I'm saying if I put the negative 5 into here, what sign do I get for my answer? Well, it's spend $5, spend $1 is negative 6, but all I care about is negative. All I care about is in the negative. I'm creating a sign table. If I put that negative 5 into my next factor, I still get a negative. If I put that negative 5 into my next factor, meaning into x minus 3, I get negative 8, but that's negative. If I put it in here, I get negative 2, still negative. You're following what I'm doing? I'm putting those values into the function, the factors. And now I'm going to decide, if I have an even number of negatives, what's going to be true about the product or quotient? Positive. And so I already knew when I plugged in negative 5, I got a positive number. And there it is. There's the 5, right? There's that number. I know that whole piece of the function is positive, is greater than 0. So this interval now is of interest to me, because remember what I'm answering. When is this function greater than or equal to 0? So this particular interval right here is good for me. You following? And I promise you, when we do sign tables in Calc 1, I'll make them a lot easier. But I want you to go through the torture that I went through. This is why I don't have kids, because my parents beat me. I didn't want to beat my own kids. But I'll beat you in here. I'm fine with that. Okay? I went through this hell. You're going to go through this hell because it's going to make you a strong math student. All right. I'm going to plug in the negative 2 here, right? We should be able to do this pretty quick. What do I get when I plug in the negative 2? Negative. What about the next one? Negative. Next one. Negative. Next one. And then odd number of negatives is going to give me a negative. So that piece is no good for me. I want this thing to be greater than or equal to 0, not less than 0. All right, let's plug in the 0. That's pretty easy, right? Negative, positive, negative, positive. So an even number of negatives will give me a positive. When Cooney asked me, or Emmanuel asked me, what's up? That's fine. Yeah, so I plug. So when I'm testing 0 into x minus 1, I'm going, 0 minus 1. That's negative 1. That's negative. Yes, that's all I'm doing. Yep. When I plug in 2, it looks like I get a positive, I get a positive, I get a negative, I get a positive. So I'm underground again. I'm under the x-axis again. When I plug in 5, everything is positive, right? So that means the function is also positive. So the ones I want are here. I want this one, and this one. So f of x is greater than or equal to 0 when x belongs to minus infinity to negative 3. Why do I have open parens on there? Because I can't get there. I can't get to negative infinity. It doesn't even exist, right? And I can't get to negative 3 because it will make my function have a 0 in the denominator. Union from where to where? What's my next interval here that I'm saying is good? What's my interval here? Yes, and inclusive. Because I can get to negative 1 and I can get to 1. So I'm using square brackets. When I can use it, I use square brackets. When I can't use it, I use open parens. Union, what? Yep, 3 to infinity, right? That's a very long process. If you don't have the process written down, forget doing it on the test, especially if you get nervous. Question? One page, front and back. If you look at, let me show you. If you look at my solutions, right? You see I have, if you look at the solutions for this test, I have 4 pages on one page. And it's still pretty readable, right? Even for my old man eyes. But I imagine you can get 8 pages on one page. So that would be 16 pages, 8 on one side, 8 on the back. Robbie? Yes. Write small. Use the back. There'll be a page that's blank right next to it. Use that. Yep. All right, next problem you asked me to do. 5.3. Did you send it to me? Brian, did you send that to me? Yeah, I did. Thank you. So this is 5.3, number 73. And it's 8 to the negative x plus 14 equals 16 to the x. So this is again one of these with a base of 2 on both sides. So this one, I can do this 2 ways, and let me do it 2 ways, because the one I'm going to have you do is not going to work this first way. So I know that 8 is 2 to the third, right? And 2 to the fourth is 16. And when I'm raising an exponent to an exponent, I multiply them. So I have 2 to the negative 3x plus 42, is that right? Equals 2 to the 4x. You so far with me, Brian? Yeah? So again, this is what you would have learned in Math 50. And then what we learned this semester, is taking the ln of both sides. And I'm going to do it that way in a second. So what do I know about 2 to the x? What kind of function is it? One-to-one. So this particular function is one-to-one. Are these y values or x values? Y values. Right, I'm plugging numbers into 2 to the x. So they're y values, they're heights. When I have equal heights for a one-to-one function, that means the x's are equal, right? So minus 3x plus 42 has to equal 4x. Oh, well, that means 7x equals 42, right? So 7x equals 42, sorry. So x is 6. Yeah, you okay? Good. Let's do it the way I want you to do it on the test on Wednesday. So same exact problem, okay? And don't let me go too fast if I'm going too fast. Quiz? Thanks. All right, nice. Same exact problem, starting right here, but I'm going to take the L. Nice, thank you. Thank you, perfect. I'm going to take the ln of both sides. What allows me to do that? I'm composing what kind of functions with what kind of functions? I'm composing what kind of functions with what kind of functions? Sure, more than that, better, more detail about it. One-to-one functions. I'm composing one-to-one functions with one-to-one functions. That's the only time it's safe. And I'll put safe in quotes, because what could happen? You get an error on your calculator, right? Okay. But what happens now to my exponents? Yeah. So I get negative x plus 14 in parentheses times the ln of 8 equals x times the ln of 16. Does everybody see what's going on there? My exponents of the argument become coefficients when I'm talking about a log function. Yes, we're okay? Yep, we learned a property. In fact, I proved it. I think I proved it. That when I'm taking the ln or any log of something raised to the power, the power comes out as an exponent. Yeah, coefficients are multiplied, right? 5x squared is 5 times x squared, right? Good. What am I going to do now? I'm going to distribute. I get negative x times the ln of 8 plus 14 times the ln of 8 equals x ln of 16. I'd like to move all of my x terms. Make sure we're okay with the distributing here, right? I'd like to move all of my x terms to one side, minimizing the number of negatives. So should I move something left or move something right? Yes. So I'm going to have the 14 ln of 8 equals x ln of 16 plus x ln of 8. Yes? On the right-hand side now, I'm going to factor. So I get ln of 16 plus ln of 8. How are we doing? I can solve for x by dividing by this ln of 16. Oh, I can combine those first. Let's do that. 14 times the ln of 8 equals x times ln of what? Nice. What did I do with the 16 and the 8? Multiplied them. Now I get x equals, yes, question? Question? No? I get 14 times the ln of 8 over the ln of 128. Where can that 14 move? Where can the 14 move? Yep. So I get ln of 8 to the 14th, which my calculator cannot handle. So I'm going to do something else. Again, I'm not going to give you a problem like this because this answer is kind of nasty. But that's a pretty good exact answer right there. We can write it as a single log, right, of log base 128 of 8 to the 14th. Or we can approximate it, and watch what I do. Ln of 8 to the 14, right? Divided by ln of 128. And look at the answer. So it's not even an approximation, it's 6. The one on your test will be approximate. Now, don't write this part, but I just want to show you what I would actually do here. I've got 14 times the ln of 2 cubed. Do you agree 2 cubed is 8? We agree that 2 cubed is 8? Yep. And I also have the ln of 2 to the, what is it, 7th power? Yeah. Right? 2 to the 7th is 128. Is that true? Yes. So I get 3 times 14 ln of 2 over 7 times ln of 2. Look at the ln of 2's cancel. The 14 and the 7 cancel, so I get the 6. So when it's one of these that you can change the bases, it will reduce to some simple answer like that. But, Brian, okay with the first method? Yes. Haven't practiced the second method yet, I think. Practice the second method. So on this test that I gave you from 2017, number 16 is the perfect example. That's your test is going to look something just like that. Anything else you want me to do? 17? Oh, the one I just said? It's okay. Oh, 17, the next one. Go ahead, Brian. What were you saying? Brian, what did you say? Oh, okay. Let me say it again, and I'll do 17. Right? Say the problem again. I have y equal or just ln of e cubed? Is what I have is what you have? Right, that's all they have. But let's see what this equal. This is 3 times the ln of e, right? Yes, you agree? And what is ln of e? Sorry. What is ln of e? Huh? Yeah, it's 1. Yeah, it's 1. So what section is that? Yeah, so this is just when I'm first learning logs and I want to use the properties of logs. So it's saying, can you simplify this? I think. What is it? What are the actual words it's saying for the problem? Okay, so I'm saying it says probably simplify this. Okay, and so that's it. 3. So what did I use? I used the power, or I could have just gone 3, couldn't I? Because aren't these inverse of each other? Right? Remember, ln of e to the x is the same as e to the ln of x, which is just x, because e and ln are inverse functions. E to the x and ln of x are inverse functions. Okay, 17. Remember, you have Monday. You have time to ask me more questions, so you get work done this weekend. Ask me questions. Send me work via email if you want to. So this is number 17 on that test. ln of x plus the ln of x minus 4 equals the ln of x plus 6. Do you see, Sina, anything on the left that you can do? You can combine this into a single ln on the left, but what do you do with the arguments? Multiply them. So I get x squared minus 4x. Is the ln function 1-to-1? Yes. Are these values that I'm circling x values or y values? Y values, good. If the y values are equal, if f of a equals f of b, a must be equal to b, right? So x squared minus 4x better be equal to x plus 6. So x squared minus 5x minus 6 equals 0. Now we're back to algebra 1, factoring a quadratic. What two integers multiply to negative 6 and add to negative 5? Almost. Yes. Yes, negative 6 and 1, yes. So x minus 6 and x plus 1, right? This x on the right is positive, but when I move it, it's got to change signs. Right? You agree? When the 6 moves, it's got to change signs. So what x values work? 6 or negative 1. We have to make sure that we don't have extraneous solutions. This is kind of saying, when I look at this, that there are two places where this height exists. But look at the ln function. Are there two places? One of these might not work when I plug it back in. Which one doesn't work? When I plug the values that I got back in, which one fails? Yes, this is called extraneous. Because when I plug the negative 1, if x equals negative 1, I have the ln of negative 1, that's trouble, plus the ln of negative 5, that's trouble, equals the ln of 5. You see, I plugged it in here, right? ln has a domain of positive numbers only. I cannot plug negative numbers in. Right? What's the calculator say when I do ln of negative 1? ln of negative 1. It says low battery. No, only kidding. It says non-real answer. It can't happen. I should check ln of 5. Oh, sorry, ln of, you should check the 6, right? I get ln of 6 plus ln of 2 equals ln of 12. Is that true? Yeah, because on the left-hand side, what do I do with the arguments? Multiply. Yes. Yes, exponentials, yes. ln of x, and e to the x are inverses. If I did it without base e, it would be y equals log base b of x and y equals b to the x. Those are inverses. But the ln is a special base e. Nice. Let's take 5 minutes or so and come back. We'll do the new stuff for today. Okay, just take a break. Let's start again at the 5 of.